Hello, everybody. Hello, Michael. What a great way to open the chat with a hello world and happy Friday, Mardy. It's 10 o'clock in the evening, so I really have got that Friday feeling, but I've just got this one last thing to do before I get to the weekend. It's just up there. Okay, so where are we? Okay, so for anyone who doesn't know me already, you probably all do because you've been here before. But anyway, I'm Claire. I'm one of the TAs at Launch Shore, also a student still in the front end of the curriculum. This is the fifth in the series of introductory workshops on Python. These workshops are designed to complement Launch Shore's programming backend prep and Python course. So last week we looked at lists, dictionaries, and sets. Today we're going to be looking at variables as pointers and mutability. So if you've got any questions as we go along, please put them in the Q&A rather than the chat, because they can get a bit lost, and I'll try to answer them as we go. Last week we had some great questions, which meant I ran over, which I think is fine. I would rather that you asked questions and we ran over. It makes it all, well, a bit more fun for me, but a bit more interactive. And then the sorts of questions you're asking are probably the sorts of questions other people are asking. When I ran through this to check the timing of it, it was quite tight. So I could always just really skim over the shallow copies versus deep copies to keep the time. So don't hold back on the questions. As ever, I'll be doing quizzes to keep it interactive, but you can code along with me. I'll be putting gists in the chat so that you can just copy and paste. And before we begin, speaking of quizzes, I'm going to give you a quick poll because we would like to know a bit more about how to help students with their launch school journey. And so we thought, what better than getting this captive audience here of people at this workshop to ask a few questions. So I'm just going to launch that now. It's 3 questions and just answer those. And while I'm doing that, I'll answer Michael's question. You've missed parts 1 to 4. Where were you, Michael? There aren't any links and you can't watch them because we are trying to create like a live experience. But these will be rerun, so you'll be able to catch them. I don't know, we've not timetabled them yet, but they will be rerun. And at the point at which they are retired and we stop rerunning them, then we release the recordings on our YouTube channel. So you can have a look at Launch School on YouTube and you can see some of the workshops we've run that we've retired, such as the Git ones and the Ruby ones and the JavaScript ones. But we're still obviously running the Python ones, so they're not going to be there for a while, but you can catch me next time. So great first question. Okay. Slurp of water while you're answering that poll. There's a free text thing at the end, isn't there? I mean, you could spend like 10 minutes filling that in, couldn't you? I'll just get the screens ready. Oh, I didn't mean to do that. I was trying to get rid of that line. Didn't mean to do that. Let's get that back up. Okay, I'll stop my screen. Okay, I'll just give another 30 seconds. So however what you've got, just oh no, I mean actually Trevor said give it 3 minutes, so I'm going to give it 3 minutes. All right, you've got another 30 seconds. Last person. Can you squeeze it in? Right, I'm just gonna end it there. You can leave a complaint in feedback. Oh, speaking of which, I'll do that before I close the poll. Anyone that needs to hop off early, I'll put the feedback form in the chat. So if you need to hop off early, please take a copy of that and please fill it in. It's really helpful to know what works and perhaps more importantly, what doesn't work. So yeah, please let me know. I am. Oh, there's someone here that's completed core. Wow. Welcome. Maybe you could help me with 2:30 because. Okay, so let's get going. So we recommend using a Mac and Visual Studio Code as your editor. So that's what I'll be using. That's what's on the left-hand side. Clear this again. Does it turn that to one? Yeah. If you've got a Windows machine, or you need to use AWS Cloud9, that's fine too. And Launch Schools Python, but contains instructions to get Python up and running in those environments too. Any problems, reach out, or you just want to say hello, reach out to us on Slack. There's a prep course question Slack channel specifically for people in the prep course. Oh, you read that as completed prep, Tom. Okay, well, that's my first bit of feedback, isn't it? Because that wasn't obvious. So I can stop being intimidated now. What's the saying? Yeah, any problems, just reach out on the prep course Slack channel. So the term variables as pointers, these are all pointer dogs, is a useful mental model to understand the relationship between variables and the values to which they're attached. So sometimes people think of variables as buckets that you put data in, but there are limitations to that. And so we're going to have a look at what's going on and see why thinking about variables as pointers and being labels is a better approach than buckets. So variables are used to label data with descriptive names, which helps us understand the intention of our code. Variables are attached to specific values stored in programs' memory, and we can change which value a variable is attached to. So when we first create a variable, we talk about assigning the variable to a value. And when we assign an already created variable to a different value, we call that reassigning. In Python, all variables are pointers to objects. So if you assign the same object to multiple variables, so I do talk about assigning objects to variables and variables to objects. So it's just talking about linking them. You can assign it either way. So if you assign the same object to multiple variables, all of those variables will reference the same object. So if we change or mutate that object, all the variables referencing the object will reflect the change. And we're going to have a look at this in action using a list, because that's a mutable object. We could do the same with any other mutable object, such as a dictionary or set, but we're going to stick with lists today. So I'm going to create two variables that point to the same list and then mutate that list. So I'm going to copy the gist link. So if you're coding along, you can go in there. I'll show you. Just opens up GitHub. You don't need a GitHub account. Let me just open this up, and then you can copy that code, and then you can just paste it in. So we're going to be working in the REPL today so that I don't need to create files, and it's all just here on the screen. So I'm just going to paste in that code that says, are you sure you want to paste in that much? It's because I've got a space in there. Oh dear. Okay, so when you're doing this, you're going to need to get rid of that space, which I can do. Okay, so let's have a look to see what we've got. So we should have dog breeds, and we've got also breeds. Okay, so what I've done is I've I'm actually going to come out of this because I shouldn't have pasted all of that code in. So let me come out, Command D. So what I need to do is do this step by step. So I'm just going to paste in the dog breeds to save me typing that out. So we're creating a variable dog breeds. It points to a list that has beagle and poodle in it. I'm then going to create another variable called also breeds, and I'm going to point that to dog breeds. So I'm just going to bring up a little diagram to show what we've done here. So we've got beagle and poodle, and we've got dog breeds is pointing to beagle and poodle. And then I've now created a second variable. I've done also breeds equals dog breeds. I'm skipping over the fact I've made a mistake there, and that should be dog breeds. So we've got also breeds equals dog breeds. Now, what we might think is that we've got the label also breeds, the variable pointing to dog breeds, which points to beagle, poodle, but that isn't what happens. What we get, let's see, it's smooth so you can see, oh, both on the same page. What we actually have when we do also breeds equals dog breeds is we get dog breeds and also breeds both pointing to the same list. So it's really important to understand that. And once you know it, you kind of forget how important it is to know it. But everything comes from here. So when you're assigning something, if you're assigning a variable to another variable, you're actually assigning the variable to the object that the other variable references. Okay. So once you understand that mental model, the behavior of code makes a lot more sense and it's just not mysterious. So just remember that variables point to objects and not other variables. Also note that without a variable pointing to an object, we've got no way of accessing that object because the objects don't have names themselves. Variables have names and they point to objects. And that can make describing what's going on a bit convoluted because we might say, you know, dog breeds references a list containing beagle and poodle. And instead we might say something like, you know, dog breeds is a list containing beagle and poodle. But that is a shorthand because dog breeds is a variable, doesn't contain anything. It points to an object that contains things. So just be aware of sometimes when we're talking, we are making a simplification. Sometimes it's fine, but sometimes we need to be more specific about what we're doing because of the behavior of what is going on with these labels. We can check that dog breeds and also breeds point to the same object using the is operator. So if I do dog breed breeds, dog breeds is also breeds, we get true. And the is operator just tells us that two variables are pointing to the same object, not that they're the same variables. We have got two variables, dog breeds and also breeds, but they're pointing to the same object. Now let's have a look at what happens if we mutate one of them. So we're going to append Dalmatian to dog breeds. So I'm going to do that with dog breeds, and then I'm going to append Dalmatian. And so now if I have a look at dog breeds, we can see Dalmatian is on the end of it. But if I look at also breeds, that also has Dalmatian on the end of it. And the diagram you can see here is because they're both still pointing towards the same object. And so we can do the same by mutating that list using the also breeds variable. So we'll do also breeds, and we're going to append, and this time we're going to append husky. And so now if we look at also breeds, we see husky on the end of it. And if we look at dog breeds, we also see husky on the end of it. Now let's have a look at what happens when we reassign a variable. So let's clear the screen here. So we are going to create a new variable. So I'm going to paste that link into the chat. Oops. Oh, there was a 1 on the end of that. Don't copy that link. Do this one. Okay, so now I'm going to create a cat breeds variable. So here we've got cat breeds, and again, it's a list. And now I'm going to reassign also breeds to the cat breeds. So I created cat breeds and it pointed to this list here, and dog breeds and also breeds are still pointing to the list of dogs. But now I've reassigned it. So I've done also breeds equals cat breeds. So now also breeds no longer points to the dog breeds. It now is pointing to the same object that cat breeds points to. So now if I do dog breeds is also breeds, I'll get false because they're not pointing to the same thing. But if I do cat breeds is the same as also breeds, I'll get true because they are now both pointing to the same thing. So we've severed the link with the dog breeds. And we can see that again a little bit more if we now mutate the dog breeds list. I'm going to append Doberman. I can see that that has made a change to dog breeds, but also breeds won't have that on the end because it wasn't pointing to the same object as dog breeds when we made that mutation. So that was all about assigning and reassigning variables and mutating objects. I just wanted to finish this section with just a quick warning about mutation and reassignment, sometimes looking similar, but they have very different effects. So it's really important not to confuse them. So let's have a look at an indexed assignment, which looks like a mutation. First of all, I'm going to answer this question. So here, variables point to objects and they don't hold the object itself, just its reference to the object. Is that right? That's absolutely right. Variables just point to objects. They don't hold the object. It's not in a bucket. They're just literally pointing to it. Excellent, sorry. Right, so indexed assignment. So let's clear the screen then. So indexed assignment is when we use the square bracket notation to access a particular element in a list. So lists are 0 index space, so we start at 0. The first one is Beagle. But not only can I pull it out, I can also reassign it using this. So I can change it to a Yorkie. So I've reassigned the first element in the list that dog breeds points to Yorkie. So now if I have a look at dog breeds, I've got Yorkie there instead of whatever it was I had before. Beagle instead of Beagle. And so this can look like reassignment, but it isn't, it's mutation. And that's because we've got this square bracket here, this index here, and that makes this mutation. Okay, so now we understand variables are pointers to objects. When using variables, it's important to keep in mind that some methods mutate objects, as we've seen Append does, while others do not, and might create a new object. So we're going to have a look at a few different methods and consider whether or not they mutate. So, and this was actually something that I was asked about last week, and I was confused when it didn't work. So I'm going to provide another gist link to lists of animals. And just copy that in. So first of all, we're going to look at how we can get the last element. Python is great and it lets us use negative indexing. So -1 will give us the last one, really useful. And so you can get last element by using the index -1. If we capture that, so -1 animal equals animals. -1. We can see if we do animals, its pig is still there. We've not removed it, but we have assigned -1 animal to the value that is in the last place in that list. So we can see that -1 is non-mutating. Now we're going to use the pop method. So if I do pop animal, equals animals dot pop, and I'm not going to pass it any arguments. If you pass it arguments, it does something different. But if you don't pass any, it just gives you the last one. So now if I look at pop animal, it gives us pig. So it's doing the same thing as that -1. But if we look at animals, it's removed it. So using the -1 index and pop both do the same thing in that they let you get the last element, but pop mutates and -1 indexing doesn't. So depending on what you're trying to do, you will want to use one of those methods over the other. So now we're going to have a look at sorting animals, which is something we did look at briefly last week. And I was very confused that the methods didn't work because they did work, and I must have just typed something in wrong. So if we do, we're going to use the sorted method. So I'm going to do sorted animals. And I'm going to use the sorted method. And then pass in the list that is referenced by animals. And if I look at sorted animals, I can see I've got cow, and I needed to reassign animals first. Wait a minute, animals equals, I wondered why I'd done that in my notes. Just because it's not very interesting with just 2 elements in there. So look, we've got animals equals penguin, cow, pig. So let's clear that. So animals. I'm now going to assign sorted animals to sorted animals. And if I have a look at that, I can see I've got them listed in our alphabetical order. And if I look at animals, I can see I've not affected that order. So what sorted did was create a new list with the same elements, but now they're sorted in alphabetical order. So this is a non-mutating method. And if I do animals is sorted, sorted animals, I'll get false. They're not the same lists. And there's another way that we can sort a list using sort. So sort animals equals, and here, this is a method invocation. So I do the variable that's referencing an object that I want to invoke the method on. So animals.sort, and then around braces because it's a method. Now, if I have a look at sort animals, nothing comes back. And the reason for that is because the return of animals.sort is none. If I look at animals now, it has reordered animals. And that's because it's a mutating method. So a mutating method returns none. So we've captured none inside sort animals. And we have reordered the original list. So I've lost penguin, cow, pig order. I've now got cow, penguin, pig. Again, both these examples use lists. And we've got one that mutates and one that doesn't. But this concept of mutating and non-mutating methods applies to other mutable objects as well. So let's look at retrieving values from a dictionary using specific keys. So again, I'm just going to paste that link in here, some different animals, and then paste in, I'll call this features. So if I do features, so we've got the keys are animals and the values are their feature that they're known for. And there are 2 ways we can get the value for an elephant key without mutating it. we can do features and then pass in, oops, the key name, and we'll get big is. And we can also use the get method. Right, so we pass in the same thing here, which is the key name. That will also give us big is. The advantage of using big is that if the key doesn't exist, you don't get an error. So if we change this to Ellie, we'll get an error. Whereas if we use get and do Ellie, it just doesn't give you anything back. So sometimes you want an error because you don't want something to fail silently. Other times you don't want an error because you want the program to just continue. It's fine that it didn't find it. Let's just move on. And then you can use the pop method on a dictionary. So if we do features dot, whoops, pop. Yeah, with that, an error is raised if you don't pass an argument because dictionaries aren't ordered. So there's no concept of a last key value pair. When we did it with a list and we we didn't pass any arguments, the default for a list is that Python gives you the last one. But for a dictionary, there is no concept of a last one. So there is no default to use, which means you have to pass an argument. So if I pass elephant as my key, it works, it gives big ears, but then if I look at features, we can see that elephant has now gone. So we can use the get method to get a particular value given a key without mutating, and then we use pop for a dictionary, like we did for this, that will get a particular element based on its key for a dictionary, and that will mutate the dictionary. There are loads of examples of mutating and non-mutating versions of methods, and this can easily catch you out, so be careful. And to determine whether a method is mutating or not, you can look at it in the Python documentation. It's probably a good idea to do that, to familiarize yourself with the Python documentation. Documentation always looks a bit scary, I think, when you first start looking at it, although Python's pretty good. And the more you look at it, the more you understand. But then you can also just try these methods out in the REPL to make sure that they're doing what you want them to do. And here, you've just noticed that the drawing is a cow, pig, Gwen. Nice way to illustrate mutability. And it's just so nice to be appreciated. You're welcome. So now we are going, well, I say we, you are going to do a quiz. These are just for fun. I can't see who answers what. I can see how many people have finished, but I can't see who answers what. And then at the end, I can share the distribution of answers, but you won't be able to see. So don't worry about, not knowing the answers. Just give it a guess. Everything's multiple choice. And there might be things in there that are, no, I think we've covered everything that's in there. Sometimes I like to pop in a curveball. But I think I haven't. Oh, we don't really have the answers. Let's leave that up. Oh, no, they're not the answers. These are the code examples that you need for the questions. So there are 5 code examples there. And zoom in as much as I can to make them visible. There we go. So give this a go. Let's make sure I've got the right one. Mutation. 5 questions, and then we'll come back with the answers together. Thank you, Tom. I was just complaining about I've got a drawer that automatically opens itself. I think when I touch it, I don't think it's haunted and it keeps making me jump. At least I wasn't saying anything important. Right, okay, so let's have a look at the answers. We'll share the results and then talk you through. So you've got example one, we've got penguins, and then we're using the bracket notation with a 1. So it's bringing back index 1. And this is demonstrating mutation because this is indexed assignment. I think I put the hardest question first. So this looks like assignment, which wouldn't be mutation. But it is mutation. I can see why some people, I think I might have to clarify that question, you know. Clarify. But the answer I was looking for, I wanted you to read my mind. I wanted you to spot that this demonstrates mutation. But it is also reassigning that first element. But the point is, it is mutation and not just assignment. Let's move on. Example 2. We've got pigs and piggies. And we are assigning we've assigned them to 2 different dictionaries, and then we're using the double equal sign to compare them. So this isn't mutation or assignment and reassignment, because this is just using the equality operator to determine if the variable is assigned to objects with the same value. So neither for that one. I do feel like I've started really. I think I want to reorder these questions. So question 3, we have got cows and we are assigning that to a set of 3. And then the second line, we have reassigned it to 2 different cows. So question 3 is assignment or reassignment more specifically. Example 4, we've got mice, and then we're using the pop method, so that mutates. And then example 5, we're using get on a dictionary, and get doesn't mutate, it just brings back the value for the key that you pass in. So that is non-mutating. So moving on. This is just an excuse to keep pictures. So when mutating objects and reassigning variables, it's useful to understand how Python interprets equality. So we're going to have a look at that next. So fundamentally, Python considers 2 objects to be equal when they're compared using the double equals, and that comparison returns true. However, you must be careful that while 2 objects are equal, it doesn't necessarily mean that they're the same object. And we refer to 2 objects as, when they're the same object, as having the same identity. So I'm just going to paste in another just link. Runaway pencil now, with a list of different sets of animals. So first of all, we're going back to our animals again. So we've got our penguin, cow, pig, and I'm going to do same animals. So as we did before, if we do animals, or we didn't do it using double equals, did we? So if we compare animals, the same animals, Python comes back and says they're true, they've got the same value. And we know this because we used the is operator before on them, and animals is same animals. They're not the same variable, but the variables are pointing to the same object. So Python says, yep, they've got the same identity, it's true. So let's have a look what happens if we create another list that contains the same strings as the list referenced by animals. So I'm going to do this manually. Let's call this also animals. And so it contains a penguin, a cow, and a pig. Okay, so it's exactly the same list of animals in the same order that animals references. And so if we compare them, Python says, yeah, true, with the double equals, they're equal, they've got the same value. But if I ask whether they are actually the same, oh no, I'm comparing same rather than also. Sorry, so let's do it again. Animals is the same as also animals. I've put 2 underscores. That took me ages to spot that. Thank you, Derek. So yes, animals and also animals have the same value. They're both a list. They've got the same things in the list and they're in the same order. But if I use the is operator to compare them, Python said they're not exactly the same list. They've got the same value, but they're not actually pointing to the same object. So it's important to be aware that when you're comparing things using the double equal sign and is, you're comparing 2 different things. So double is comparing, Python is going, are they equal? Are they, you know, for a list, equal means same things in the same order. Whereas is saying, are these variables pointing to the same object? So let's have a look at this with a dictionary. So let's clear that. So we've got here, we've got calls. I've got for the keys, I've got the name of the animal, and then the value is the call that they give. And then I'm going to do the same thing. Call it also calls. It's got the same keys in the same order with the same values. And if I say, are they of equal value, Python says yes. But if I say, are they the same, then Python says no. Now, interestingly, no, okay, I'm going to go on to that. So we can do the same for sets as well. So here, we've just got collective nouns. And you see, I really want the animal thing here. And then also collective nouns. We've got the same things. Again, if we do collective nouns, is the same as also collective nouns. Yes, they have the same value, but if I go back and say, yeah, but do they have the same identity? Python says, no, they don't. Now, be careful, because with lists, order matters. So I've got my animals. If I do more animals, I'm going to create another list. But I'm going to put them in a different order. So I've got cow, and then penguin, and then pig. So we can see these are 2 lists that contain the same elements, but they're not in the same order. We would expect animals is more animals to return false because they're 2 different lists. Yeah, false. They're different lists, so that's great. But they are also, as far as Python's concerned, completely different values as well. And that's because with lists, order matters, but it doesn't for dictionaries and sets. I'm just going to show you that for sets. You can try it yourself for dictionaries. So we've got collective nouns, and then we've got more collective nouns. I've put the same words but in a different order. When we compare them with the is operator, Um, uh, they're not the same. We know they're not the same because they're two different sets that we've created. But if we compare them with the equality operator, we can see that Python considers them the same. So unlike a list with a set, order doesn't matter. If it's got the same things in it, then they're the same. And the same for a dictionary, because dictionaries don't have order, which is why we don't have a last one. It doesn't matter whether the keys are in the same order or a different order, as long as both dictionaries have the same keys and for each key they've got the same value as one another, then Python considers them to have equal value. And when you compare them with double equals, it will return true. Okay. So now we're going to do quality and identity. Oh, I'm going to have to make that. I don't want to make it smaller. Oh, look at that. It's like I judged it. I've actually checked. So give this a go. And then we'll have a look at the answers like we did before. This is 6 questions. I'm not going to mute myself this time because it's too dangerous, isn't it? There aren't examples for questions 5 and 6. No. Great question. You see questions 3 and 4 are controversial. Okay, I'll give you another 30 seconds or so. Okay, so let's have a look at the answers. I do think it's quite difficult looking at code snippets on the screen and answering a question in Zoom. So don't worry too much about this. Right, so for the first question, what have we got here? Everyone got this right? So we are comparing hamsters and more hamsters. They are sets. They've got the same things in different orders, but sets don't care about the order. So when we compare them with double equals operator, Python says, yeah, they're the same. Then for question 2, when we look at hamsters, is more hamsters, we get false because these are 2 different sets that we've created. So they do have the same things, and sets doesn't care about the order, but is comparing, are they pointing to the same object? So we get false. Then example 3, we've got our fish, and then we're assigning more fish to the fish. Then we are using indexed assignment on this dictionary to change what we've got. Oh no, not change, we're adding a new key. So we're changing the dictionary to add a new key with tropical and a new list, beta and molly. So now if we compare fish with more fish with a double equals, we're going to get true. And actually, if we used is, we would also get true because we've assigned more fish to fish. They're both pointing to the same dictionary, so they've got the same value. So if we use double equals, we're going to get true. And if we used is, we would also get true. For example 4, which I'm answering there, it's the same thing, and then we're comparing fish is more fish. We're going to get true because they are both pointing to the same object. So I can see why, if question 3 was difficult, question 4 was also difficult. So questions 5 and 6. Which of these is used to determine whether 2 objects have the same identity? We use is. And which of these objects is used to determine whether 2 objects are equals? We're using the double equals sign. So the more you use these, you'll just get used to it. And it is very handy that Python has these 2 different things, because sometimes you want to know whether things are just kind of equal in value. And sometimes you want to know whether 2 variables are actually pointing to the same thing, particularly when you're debugging. Okay, so we're running about 10 minutes over. So I am going to, can I explain questions 3 and 4 again? Yes, I can. Here. So we have assigned more fish to point to the same dictionary as fish. They're both pointing to the same thing. So when we compare them using double equals, we're going to get true because they're both pointing to the same dictionary, so they've got the same value. And then when we use the is operator down here to compare them, we're also going to get true because they are both pointing to the same thing. We know that because we assign more fish to fish, and that doesn't assign more fish to the variable fish. It assigns more fish to the object that fish already references. So I hope that helped. Got it, thanks. You're welcome. So now I'm going to quickly do shallow copy versus deep copy. I just wanted to hover there for you to appreciate that. So I'm going to paste in a gist link. So what we're going to do is we're going to import copy. So we're just going to take this on faith. You can use import to import some code that somebody else has written that has some useful methods in it. And this enables us to create deep copies, and also enables us to create shallow copies. We don't need import copy to create shallow copies because there are other ways, but we do need it for deep copies. And so I'm just going to use it to create shallow copies as well. So first of all, I'm going to create some nests. And because we're creating nested lists, I used bird names for it. So here we've got a list, and the first element in that list is itself a list containing 3 types of birds, and then the last 2 elements are birds themselves. Now I've chosen to represent this by having, we've got nest cell variables is pointing to the green ellipse here. And the first element is a pointer to the sublist, and then the sublist is over here. So we've got barn, snowy, tawny here, and then the other two birds in there. And you'll see later why I've chosen to have a pointer to the sublist. So now, if we create a copy, do you know what? Rather than doing it over here, it will be quicker for me to just go through this here. So we've imported copies so we can do this. We've created nests copy, and we have assigned it to copy the module dot copy the method. So the module and the method have both got the same name, which is a bit confusing. But copy the method, and copy the module and copy the method, and then we pass in the thing that we want to be copied. This creates a shallow copy. So here we've got our nest copy. It creates a new list containing the same things as the list that we copied, including the pointer to the sublist. It doesn't create a whole new sublist. It just creates a list with the same pointer as the other list had. So they're both pointing to the same one. Now, this is important because if we mutate nests, so nests 1 is referencing, oh, I can't click on that, so it's a screenshot. Of course it is. So nests 1 is pointing to the element that's at index 1 in the list, referenced by nests, which is now going to point to Crow. So it was Robin, but now it's Crow. And we can see that that will have affected only the list referenced by nests, because it's a different list to the one referenced by nests copy. And I've done the same thing here. So nests copy, I've used index 2, so that's the last one. It's gone from being parrot to loon. And again, that has only affected nests copy and not nests because they're two different lists. But if instead we mutate the sublist, so to access a sublist, you use adjacent square brackets. So this is saying for nests, the item at index 0, which is the pointer to the sublist. So it's the sublist. So we're in here, so we go over here. And then we've got 0 again. So it's the first element in that sublist. We're reassigning to little because both nests copy and nests point to lists that contain a pointer to the same sublist. When we mutate it using the nests variable, nests copy will also reflect that change. And we call this a shallow copy because we have created a copy of the list, but if there are any sub data structures in there, like a sublist, it won't create a new one of those. It will just have a pointer to the same one that the one that you copied from does. That was a bit of a mouthful. So now we're going to create a deep copy. So we're going to do that using copy.deep copy. Less confusing now. So copy is the module and deep copy is the method name. So we're saying create a deep copy of the object that nests references. And we can see down here what happens when we create a deep copy. Like before, we create a new list and it creates a pointer to the sublist, but this time it's created a new sublist. The shallow copy just pointed to the same sublist that the one that you were copying pointed to, but the deep copy creates its own new sublist. And so it's called a deep copy. And actually, it doesn't matter how deep that nesting goes. A deep copy means that anything as deep as it would go, because you can nest lists within lists within lists. A deep copy will create a copy of all of the nesting structure underneath. It won't have pointed to the same list that the thing that you're copying. Sometimes that's really important. You want to create a copy of a list for example, and you want to be able to mutate that list without affecting the original one. And if you want to do that, then you need to create a deep copy. Sometimes you just want to create another variable that is assigned to, sometimes you just want to create a shallow copy. So you're creating another variable that contains this, a new set of elements, but doesn't create a deep copy of any of the nested things, in which case you use copy.copy, so that's a shallow copy. Actually, kind of by default, most ways in which you create copies are shallow copies. So if you create a copy using list, so let's call that nests copy using list. So we can use the list method, and then we can pass in our variable that points to a list. This is a shallow copy. And the same can be done. There's a way of doing it using slice. And this is a bit cryptic if you don't know, but you know, slice, you pass in colon delimited. You'll start, you'll finish steps, I think, to copy another list. If you just pass in a colon, it just copies it from the beginning to the end. So effectively, it's creating a copy of the list. And again, this is a shallow copy. So if you create a copy of a list or any other data structure, I would assume that you're creating a shallow copy unless you're certain that you're creating a deep copy. You have to be quite deliberate about it. You have to use import copy, copy.deep copy, and then you'll be creating a deep copy. So just assume that you created a shallow list unless you've gone to the trouble of creating a deep copy. Okay, so that was the last topic. Anyone that needs to head off now, because we're right at the top of the hour, I'm going to put the feedback form in, but I want to leave some time for you to answer some questions. And while I'm waiting for the questions to come in, I have got another quiz for anyone that would like it. So would anyone like the last quiz? I only need one person to say yes. Perfect. Well done, Shelby and Alicia and John. You're my kind of people. Round up quiz. This is a good meaty 8 questions. So give that a go. Yeah, and if you've got any questions for me, put them in the Q&A and I can answer them after we've gone through the roundup quiz. Fan my computer's getting very hot. Oh, wow, each of you have already completed it. Just give you a bit more time. Okay, another 30 seconds and then we'll have a look. I haven't got any questions in. You sure? No questions at all? No sort of, should you put cream or jam first or scone? Are you sure? What's that? Someone else. Oh, someone did ask with the community update. Do Brits refer to cats as kneading biscuits when they're doing that kneading thing? And yes, we do, because biscuit dough does need light kneading. So we do say that. Yeah. Right, okay, so let's have a look at the answers. Show these results. So here we've got variables can be assigned to multiple objects. False. So a variable is assigned to one object. That object might contain pointers to other objects, but still a pointer, a variable is only assigned to one object, but objects can be assigned to multiple variables. So many variables can all point to the same object. Maybe I should change those questions to say point to rather than assign. I think that's ambiguous. Right. Question 3. When thinking of variables and their relation to the data assigned to them, is it more appropriate to think of them as buckets or labels? Labels. Because if you put data in a bucket that is a variable, but then you want to point another variable to the same stuff, and that variable is also a bucket, how do you represent that both those buckets contain the same thing? I don't know how to draw buckets to show that. So it's better to have labels because then both the labels can point to the same thing. Question 4, this is indexed assignment. We're reassigning the first element, number 1, to 99, so that's mutation. Question 5, we've got an empty set and we're creating a new key for that. I'm assigning colours, the key to list red to a set, red, green, blue. So that's also mutation because we're creating a new key for that set. Question 6, we've got numbers equals a list. Well, that's assignment. Then question 7, we've got the list 1, 2, 3, and we're using double equals to compare it to 3, 2, 1. So this is comparing two different sets, but they have the same things in them. And so Python says, yeah, double equals, they've got the same value. They're not the same set, so is would return false. But when we compare them with the double equals to say, do they have the same value? Python says, yes, they do. And then what does this create? List, and then we pass in a list. This creates a shallow copy. Remember, everyone got that right. Brilliant. Well done. Right. Okay, so I haven't got any questions, so I'll just quickly recap what we went through. We did variables as pointers, not buckets, just so that you can have two variables pointing to the same thing without somehow the same stuff being in two buckets. How can that be? How can we have the same stuff in two buckets? Maybe it's the buckets inside each other, but no, but then one of the buckets contains another bucket as well as the stuff inside the bucket. It doesn't work. So variables are pointers. And when you assign a variable to the value of another variable, actually, you're just pointing, thanks, Tom. You're just pointing both those variables to the same object. Then we looked at mutability, so that some methods and functions mutate things and some don't. So you need to be sure which each method and function you're doing is doing. It's important to know whether something is mutating or not. So you can just check it out in the record or look in the documentation. We looked at equality and identity, so using the double equals and the is. So is checking, are these two variables pointing to the same object? The double equals is saying, does Python think they've got the same value? So for lists, that's the same things in the same order. For sets, that's the same things in any order. And for dictionaries, it's the same set of keys and each key has got the same value. Then we looked at shallow copies and deep copies. So a shallow copy will create a copy of another, we'll just talk about lists. We'll create a copy of another list, but if there's a nested list in there, the new copy will contain a pointer to the same nested list that the original does, whereas a deep copy will create a whole new nested list. And that counts no matter how deep the nesting is. So, you know, as ever, the important thing is to go in and practice this. Go into the Launch School Python prep course book and work your way through it and look at the exercises and do the exercises. It's doing stuff over and over and over that really gets the memory going and, you know, just understanding and making those mental models more concrete, consolidating everything. And work with other people. Again, if you can explain something to somebody else, then you really understand it. So next time, we are going to be, oh, I've got that in the slide. That's not there. So next time, we are going to be, oh no, I didn't know that. We're going to be doing small problems and debugging. So we're going to be looking at solving small problems using the PEDAP process. We're going to be looking how to effectively debug your code. This is a very interactive session, so I am going to need you all to turn up and take part because we're going to solve the problem together. So I'm going to have a problem up and I'm going to be asking you to contribute as to how we go about solving that problem. But then I'm also going to be showing a few tips and tricks about debugging code. Okay, so that's the last thing. So said it before, I'll say it again, please fill in the feedback form. It's really helpful. We are always modifying things, always making changes, and it's based on everyone's feedback. So fill it in. If it's worked well, then I'd appreciate you saying, Claire, it's brilliant, it's perfect, don't need to change a thing. But equally, I would appreciate it if you just say, Claire, not long enough for quizzes, Claire, too much content, or too fast, or you know, why are you putting in cartoons? Because I can. And cute pictures of cats, because I can. So some things I might ignore. If you say too many cute cat photos, I might take that with a pinch of salt. So enjoy the rest of your Friday, everyone. It's just 50 minutes to midnight now for me. So it really is the weekend, and have a great weekend. And hopefully I'll see you all next week. It should be a fun one because you have to all get involved. And thank you for all your contributions and your help when I'm muted and spotting my mistakes and stuff. It's really helpful. It's just a lovely group. So goodbye.